Okay, thank you very much for inviting. Actually, see lots of new faces, known faces, new faces too, and familiar faces, no? Because with Maria and the team, we've been working on in this advisory group for a short period of time, but very, very intense, in a very, very relevant time of our technology roadmap, no? So what I'm going to talk is a little bit, first I want to do a little bit of elevation pitch of who's Openchip for the ones that you guys don't know who we are and what do we do. And then I'll get into a little bit on the technology landscape and where we are in Europe. No? And I think it's going to be nicely connected with what my colleagues have presented already in the form of Chips Act 2.0, European sovereignty, and things that we need to do in Europe. So who's Openchip? Openchip is a project, is a company that got started. We started operations like 2 years ago now. And myself, I've been working in semiconductor for more than 25 years, most of my career in American semiconductor company. So one of the first things for me to say is that thanks to the European Commission and thanks to the support of the public institutions, myself and a bunch of other talented engineers that they've been working in the semiconductor area for more than 20 years, we were able to start this adventure. So today, our Openchip, we have like 350 engineers with an average seniority in this field for more than 15 years. And people that is coming from many different companies that are not European. No? And for me, the first thing that I want to mention is talent. Talent is extremely relevant because myself, when I started at Intel, why I started there is because there was no other companies in Europe that they were doing such advanced design systems as we are doing at Openchip and other companies like Accelera. So that's the first thing. And we need more talent to come in the next decades to fulfill the opportunity and challenge that we have in Europe. We have presence in different parts of Europe. We started in Spain and Italy, but then we grew in other countries. It was basically a matter of velocity and expertise. As I was mentioning, doing the type of work that we are trying to do needs a lot of expertise, and that implied that we had to open offices in places where there is talent that we can gather together, and especially in our case, so we were coming from companies like Intel, so we were capable to attract big teams in each of these locations. What do we do? So just for you, like we do chips, no? Like as we were saying, like Maria was telling about the nano chips. So we do nano chips, but those chips have to be embedded into a system. No? So that means that our goal is to provide not only the chips, but as well the hardware that goes into the data centers. And more important is not only about the chips and about how they get embedded into these cars that are the ones that you typically see from other AI companies in the other side of the pond, but also on the software. No? There's one aspect that is extremely relevant. I'm going to talk about this in few slides. But basically, like if I ask to you guys, probably if I ask which chip you have in your phone, you will have no idea. What you will know is the app that you're using in your phone, what are the capabilities that it provides. So that means that there is no sovereignty if you don't have hardware and the software intertwined. Here it's something I want to, and I'll talk a little bit about that as well, is that this is not about only Openchip. It's really about the partnerships that we establish in Europe to fulfill all these needs that you guys have in terms of compute and how we provide them in European data centers. Now, I think it's extremely good news, like what we saw in the European Chips Act, because basically it's a first step towards having these vertically integrated stacks done in Europe for Europe. And as I will cover in a few slides, now it's more critical than ever that we do that. So with that, let me jump into, actually, I know that the title talks about RISC-V, but I'm going to talk a little bit more generically, because RISC-V is one of the ways to achieve or to break dependency in proprietary technologies. But at the end of the day, what we need is to have open systems that help you guys to choose in an open market. So how many of you guys know what is agentic? Can you raise your hand, agentic AI? Okay, who of you guys know what is ChatGPT? Okay, good. So basically you don't know agentic, but you may not know agentic, but the reality is that all the AI tools that you guys are using today are built on what is called agentic AI. And agentic AI is something that it's being more and more permanent in the last few quarters, and basically it's a new way to implement AI. If you look like 1 year ago, like the most applications where you have an application that use a big AI model, and then that AI model does something for you. But now that has changed. And we have agents, and what agents are entities that they use models to perform actions. So I think it was a month ago, I was in the SUSE AI Summit, and it was very interesting because I saw one company that they were saying, in our company, we have 50 engineers. And then the next slide was, we have 10 persons and 40 agents, okay? And this is not about debate about human versus agents. It's really about how do we work together. But the important fact here is that now, I'm going to skip this one because obviously the more agents you need, the more compute you have. But now the real question is how we're using that in Europe and what are the dependencies that implies. And I'm going to deep into that. The first thing I want to mention is on this single model versus having lots of agents working together. So obviously, that comes with a lot of compute demand, which implies cost, okay? And probably you guys have seen that over the weekend, for example, like the Anthropic and GitHub, what they have done is start increasing the prices to reflect this compute and power demand, which it's going to change, like obviously how companies are using it. The second is, okay, this energy is sustainable, is not sustainable, and how much we can shape the power consumption in the systems that we do. And more important, the third aspect is how the data is being treated. These 3 slides are the slides that I presented in IMEC ITF 1 year ago, and it's interesting how they become, they are still relevant 1 year after, no? Compute demand, where that compute is coming from, cost and energy, and the third is data sovereignty and compute sovereignty. Now, the question is, now I made the question about ChatGPT, who is using ChatGPT. So the interesting part that you see is that now the companies, what they are doing is adapting. It's not only about you guys using ChatGPT to ask how you summarize your agenda whatsoever. Now there is a change on how companies are operating. From HR perspective, from legal perspective, like there are lots of agents that can be used to augment the capacity on how we operate in the different parts of the organization. And if you see, like now, I was in this economic event yesterday, I was talking to a couple of the CEOs of big companies here, and they were telling me, oh, my board is asking how do I invest like 2 million in AI? And that implies that you're going to change how your company is operating, maybe shifting resources here and there, and make that most of the departments of your organizations are using AI to do certain tasks, from legal document analysis to code development, to traveling, to agenda management, etc. And this is why I call the agentic soup. Now let's say, okay, so these tools are becoming available, and now you say you are a company, a bank, and now you say, okay, I'm going to change the way that I operate and the people, how they work, and I'm going to start utilizing those tools. Fantastic. And now what you have all of a sudden is that you are changing the way how your corporate infrastructure is working, the engineers, etc. And now you have some agents that are being used by you guys to develop code, to manage agendas, to analyze documents, etc. And those agents have to run they are using AI models. You guys know, ChatGPT is an agent, has multiple agents, and it's using the ChatGPT models to do the task that you are asked it to do. And obviously, these agents and this AI are running into a particular hardware and in a particular infrastructure. Now, guess what? Today, if you look at many of the companies, they are very intertwined with the services that some non-European companies provide. So, okay, I'm going to embrace all the agents that, let's say, Microsoft provides, just as an example, and I'm going to change my company to use those agents. And now, okay, I'm going to use AI models. Fantastic. So I have AI agents that are provided by one company that run on agents that are provided by another company. Now, the third question is, okay, now I'm going to have my hardware infrastructure, okay, that runs those agents and those AI models. Fantastic. And then I will have some hardware underneath, no, like we do at Openchip, or that today, if you look at many, like 90% of the deployments, they are running NVIDIA, AMD, Intel, et cetera, et cetera. So now I have hardware as well as part of the equation. So the question is now what happens? Okay, so you as a company, you have changed the way that you operate. You have changed how you do legal, how you do stuff based on this completely integrated, super cool, agentic infrastructure. But now you get that someone, those companies that are not here in Europe, now they say, okay, look, you know what happens is that the cost of my services, they were a little bit under the value. So now I'm going to charge you 5x more. Or, for example, there is some export control law, and I will say, okay, look, you got this hardware, but now I'm not providing that to you anymore. Or you say, okay, we have more demand in our continent, so I'm going to provide you hardware as it becomes available. So now what happened is that you, as a company, you have built your own strategy to on top of a vertically integrated stack that you don't control. Okay, and that's why, like when we talk about openness of solutions, are not only open solutions in the terms of the hardware itself and RISC-V as we were talking. It's about the entire value chain. And that's what's very important, that now when we look at designing technology here in Europe, we have to look from the chips that are the engine of the systems. We have to look at the next levels and making sure that we have ways to diminish the dependencies that we have external. So in that sense, I think that's reflected in the work that we have been doing together for the last few months. We need to have open mechanisms, open standards that help us to basically adopt European technologies in a cohesive manner, that they are using standards that allow you to intertwine, combine different solutions, and looking at this at the system level. And here, if you look, going back to the examples that I share, no? So now the first layer on the bottom, you can have hardware and chips, okay? And the first language and the language that these guys talk is the instruction set. And basically, I don't know how much you guys know of architecture, but basically it's the way that the applications talk to the hardware. Today, if you look, there are instruction sets that are proprietary, there are ARM, x86, et cetera. That's the first level of vendor locking. So what we need is to have an open standardization way to talk to the hardware, and that's where RISC-V comes. But now you have as well ways to manage that hardware. That's the next level, that's infrastructure. Today, you guys are, or we're using, myself as well, Microsoft Azure to manage our systems. So how we can have an alternative to that, so that when there is a kill switch, we can have software managing that hardware. And the next one is on the top, the AI stacks. That's equally important, because now if you have a dependency on the brain, that the models, you don't control that. You can have all the hardware that you want, but you won't be able to operate in an intelligent manner. And then on top, you have the applications. So, the current situation, if you look where we are, and I'm very glad on the directions that we're taking, and Ode was saying that, so now on how do we do the velocity to implement those things, those frameworks. But we need to move from more the real estate sovereign design into this vertical integration. And Maria mentioned that here in Europe we have all the ingredients to do that. And again, this has to combine the hardware and the software design. And we have to make sure that that combines not only small devices, not only data centers, because obviously data centers are relevant, but that we have a solution that encompasses things from edge to cloud. Now, here we have Infineon that actually Europe is very strong on those type of technologies, no? Like the embedded devices, the low power devices, the edge devices. And we need to make sure that when we have like these solutions from the software on the bottom, hardware, and the vertical stacks and the applications, that we manage both edge to cloud. And I think that this is especially important when we think on technologies. And in this matter, if you, for example, use RISC-V and use RISC-V on both ends, no, on the device and on the data center, now you have more portability with your applications into the different pieces. What is super important, no? And that's one area where we are, in our case, in chip design, very much focuses on the security. Okay, security and safety is extremely important, and I think that here, combining some of the elements of European elements that we have in terms of the CHIPS Act, but also other frameworks like GDPR, etc., we are in a good place to implement like systems that are more aligned with what the values or the requirements that we have here in Europe. Scalability as well. I think that's another aspect that RISC-V provides you as well, for example. So it's important that when we build solutions here from hardware perspective, we have elements that we can combine to derive different verticals. So for example, today we're working in healthcare, we're working in critical infrastructure, and now you have to have different elements that are based on the same kind of language I was talking about, that you can combine and provide different solutions. So coming back to the picture that and sorry I'm skipping some slides, but I want to catch up sometime so you guys can have lunch at the time that you guys are supposed to have it. So one important aspect I want to, and here is like just some names of companies that we're working with, but the important thing is that we, here in Europe, we have enough elements to drive those systems that I was talking about. We have companies that are developing agents. We have companies that they are developing models. We have companies that they are developing infrastructure, both at the software level and at the hardware level. And we have companies that they have public and private clouds. And I think that this is extremely important because now, if through these investments that we are having, we are capable to develop and do these vertical integrated solutions, that's something that we will be able to deliver what we are outlining in the CHIPS Act 2.0. Now, coming back to the RISC-V topic, and apologize because I know that the title had RISC-V, but I thought it was important to provide you guys an overall picture of why this is relevant. At the end of the day, this is about having freedom to choose the solution. And one of the good things that RISC-V provides us in terms of availability of ingredients that you can choose and pick for your systems is that RISC-V is open. So that means that it's good for innovation because any company can use RISC-V to develop their solution. And there is a plethora of different companies that are doing that. So that means that you can choose Openchip, you can choose Accelera, you can choose Semidynamics, and you can integrate them into the same hardware infrastructure, and you have choice to match whatever you need. So one important thing, though, is obviously that requires time. Okay, so even in our case, so we're developing chips, and you know that cycle time of the chip development is minimum 2 years. And one of the things that we believe that is necessary is not depend only on the chip availabilities. Europe has to work on having its own software stacks and APIs to access to the systems. And that's why we think that we have to work on on a phased approach where basically we start working on a shim layer that abstracts you guys as users from the hardware, and you can start using that software layers to develop your applications, to shape your organization. And now as the European hardware becomes available, you can start pulling it and independent to be vendor locking. And I think this is especially important because like the question that I made to you guys on who knows the hardware that you have in your phone, and probably none of you guys know. And you don't want to know, right? But what you want to know is that you have the right hardware. And here, one of the things that we need is to have a phased approach because we'll have to have European consumption, but that's going to take time. So that's it. I had one video. I won't share it today, but basically, I want to share with you a little bit something that, for example, I'm doing in home, which basically is developing my own stack. And sometimes people tell me, why do you do that? No, but it's to prove that really we can do many things here with simpler solutions. You don't always need to go to these very cumbersome and complex systems that are provided by the big companies that you guys already know. And I think that we need to kind of do a little bit of journey here in Europe to understand the best use of AI. And I want to finalize just in 30 seconds on reflection on that, because I think it's important that the companies that are utilizing AI today, that we're working in a daily basis, they do the effort on understanding what use cases they have and understand how those use cases get translated in what are the technology solutions that are there. And in many cases, it's not going to be things that are on the cloud, things that you probably have you can have your own solution in premise with open models, with open frameworks that are available out there. And obviously look at this roadmap, not to have your own independent or not vendor locking solution. So hopefully, that was provided you a little bit of view, a little bit different view from the silicon semiconductor domain, and hope talking to you guys over the course of the day. Thank you very much. Thank you.